Right, so in this video, we are going to discuss the topic in chapter 2, which is functions. Alright, so let's start with the first learning outcome. Okay, so for the first learning outcome, we are going to understand the term of function. Okay, so before we go into the term of function, we try to understand the meaning of relation first. Right. Okay, so what's the meaning for relation? So the relation between two sets is actually between the is the relation between the two elements, all right, between two set of elements, and then the first set of element we call them as domain, and also the element for the second set we call it as range. So we can actually draw the relation of function, right, in the arrow diagram. So what is the meaning of arrow diagram? As what you can see here, I try to draw it in these 4 different arrow diagram. Okay, so let's have a look for the different types of relation here. Okay, so we are having 4 types of relation, right? So we are having one-to-one relation, we are having many-to-one, we are having one-to-many, and also many-to-many. Okay, so maybe before we have a look for all the relation here, right? You can see that we are having one set of value on the left hand side and one set of value on the right hand side. Okay, so usually for the value on the left hand side here, the whole set of value here, we'll call them as domain. And then for the second set of the value, right, we'll call them in general as range. Right, and all the arrow that we draw here basically means some certain relation or formula, okay, between these two set of value. So you can call them as relation, or maybe later we'll make it as a function. All right, and basically the relation of function try to link these two values together. So that's a general idea on function. Okay, so you can see that for this part, we are focused on relation first. Okay, so we are having 4 types of relation here. Basically, the first type is one-to-one relation. What's the meaning for one-to-one relation? So you can see that basically one element on the domain will be mapped to another one element on the range. So we call them as one-to-one. As an example, every single value in the domain will be mapped to another value on range. Okay, so there's no overlapping for domain to range, right? So it is, you can see very clearly the one number will have one arrow sending one number to the range. So we call this as one-to-one relation. So second type, we are having many-to-one. So many-to-one relation means that in your domain, you can see that you might have more than one values that is mapped to the same value in the range. So we call this as many-to-one relation. And the third type of relation would be one-to-many, where you can see that the value, some of the value in the domain will be mapped to more than one value in range. So as an example, for this value A can be mapped to value C, D, and E, okay, in the range. So we call this as one-to-many relation. And the last type will be the combination of everything, where we are having many-to-many relation. You can see that we can have one-to-many relation in this relation and also many-to-one relation. Okay, so in general, we are having these 4 types of relation. All this we call them as relation here. And then if you want to focus into a more detailed relation, right, we will call them as function. So what's the definition for function? Okay, so this is very important. So please make sure that you highlight it. Okay, so for function, it is actually a special case of relation where every element of one value in domain, okay, assigned to one and only one element of the range. Okay, so there are 2 important keywords here. Okay, first of all, you need to make sure that you can see every element in domain, every. That means when you are having domain with a few values, right? Okay, every element must be mapped to a value in the range. Okay, so the keyword will be every element of one set domain is assigned to one and only one element, okay, for the range. So another keyword would be one and only one. That means the value in domain is mapped only to the only one value in range. which means that one to many and also many to many will not be function. Okay, so this one to many is not function. It is just purely relation. What is the reason that this is not a function? Because you can see that it didn't fulfill the second condition here. For second condition, we need to ensure that the element is mapped to the only one element in the range, right? But this value is mapped to more than one value in the range. Therefore, it does not fulfill the condition for the function, the definition of function. Therefore, this is not a function, it is purely just a relation. Then if we have a look for many to many, right? Okay, so again, when you're having many to many, you can see that this particular value b is mapped to two different values, which also not fulfill, okay, the second condition. It is not what mapped to one and the only one element on the second set. Therefore, this is also purely relation only and it is not considered as a function. Alright, so in short, out of these four types of relation, basically we are having many to one and also one to one belongs to function. So the first two part here, okay, so the first two relations shown in the notes, this one belongs to function. Okay, because you can see that every single element will be mapped to one and only one element, okay, in the range. So for many to one also the same thing, they fulfill the two condition or two definition for to become a function where every single element will be mapped to one element, okay, in the range. Alright, and please take note that the definition for function doesn't consider the range. So that means if there's a value in range, it's not mapped with any other value from the domain, it is okay. But if you have a look for the definition, you have to make sure that every element in domain, that means all the domain value here, must be mapped to one value in the range. So please make sure that you are clear about the important keyword to make the relation become a function. So these are the two important keywords for function. Right? Okay, so once you roughly know what's the difference between the relation and function, and now let us have a look. Usually for function, right, they will write it out in the form of f and then with a variable x, then denote by the formula or the relation that is map this domain and range together. So as an example, I can have fx where it is equals to maybe 2x squared. Okay, so please take note that you can actually try to change the variable here, the variable x accordingly, okay, according to the needs of your question. As an example, if let's say I'm having fx equals to 2x squared, how about if let's say I want to change x become 3y? So what you need to do is like, you need to copy the function formula and then you try to change the variable x become the variable that you want to replace. So from here, x, I want to replace it by using 3y. In the formula also, 2x squared, the x here, I will replace it with 3y. And then the formula is the same. So I'm having 2 bracket 3y squared. And then you can continue to simplify it. 3 squared is a 9. Then you're having y squared. So if you continue to simplify, you're having 18y squared. So the original function is fx equals to 2x squared. When you replace the x become 3y, you try to replace the x in the formula by using 3y as well. Then you can continue to simplify. Alright, so this is a very general idea on function. Okay, so let's have a look for some example here. Try to have a look for example 1. Okay, let's say fx is given by having this formula. So fx equals to half x squared plus 2x minus 8. Right? Okay, so for the basic one, let's start with the basic idea. If let's say I'm having f4, that means you want to replace the x by using the value 4, and you are trying to copy the formula, half is a half, and then x squared become 4 squared, 2x become 2 times 4, and then minus 8. So you can see from here, we are trying to change the x become 4. Alright, then you can simplify all the value in this formula and you get the value 8. Okay, so this is something very basic that you need to know when you're having or given a function. How can you change or how can you get the value for the function according to the value they want you to replace with. Okay, so another example for part B, f negative 1. So that means now you want to replace the x by using negative 1. Okay, so copy the formula, half, and then negative 1 square, then plus 2 with negative 1, then minus 8. Okay, so from here again, after you replace all the x by using negative 1, you try to simplify the whole equation here, and you're having the value negative 19 over 2. Right, and then the replacement of the variable is not only restricted to the value. Okay, so as example, if let's say my original formula is fx, and then they want you to find out f2x, then express your answer in this form. So how can we actually do this? Okay, so for part C, you can see that now I want to replace x by using 2x. Again, copy the general formula, the original formula, replace the x by using 2x. So x square will become 2x, the whole thing squared, plus 2x, that means x, I replace it by using 2x also, and then minus 8. Okay, so for this question, they actually try to, they are requesting for a certain pattern, which is this pattern. So that means after I find out the f2x, I need to replace it become the completed square form. Okay, so before I can change it become the completed square form, I try to simplify my equation first. Okay, so eventually I'm having 2x squared plus 4x minus 8. But this is not the completed square form, right? Okay, so apply the concept that we learned in maybe chapter 1, the quadratic equation. You try to replace it into the completed square form. So I factorize out the 2 first before I can complete the square. Alright, and then after that, I will try to plus 1 square minus 1 square. So I hope that you still remember the technique that we learned in chapter 1, where we try to complete a quadratic equation. Alright, then continue further from here. Okay, so I'm having to rephrase the first three term become x plus 1 square. Then this one I'm having negative 5. Alright, so if I refer again, the request for the question, they want us to have an a in front and then plus c at the back. So that means I can multiply the 2 with the bracket and also multiply the 2 with the negative 5. So if I try to simplify it, I will have 2x plus 1 square, then minus 10. So you can see that this is actually the pattern that they want us to rephrase into a completed square form. Right, okay, so this example 1 actually just try to show us okay, how to replace the original function with the variable x with some other value. Alright, so this is what we want to discuss for the first video in chapter 2.